Okay, I will talk about our work on integrating sensing, learning, and communication for 6G and also beyond 6G, because there are many applications that will probably need some more years. In this special issue, we focus on providing a vision for this technology. We were discussing the integration of localization and communication, in general, environmental sensing or target sensing and communication. And we focus on single link modalities, basically monostatic sensing, bistatic sensing. And we discuss applications to different verticals like automated factories, localization of vehicles in urban canyons, or drone detection. But the main contribution was basically describing the technology challenges and solutions for these single link formulations. There are also other integration aspects that we need to consider in ISAC, which is the integration of different modalities for sensing and also sensing configurations. ISAC is not only about using the waveform that we have for communication for sensing, it's also about integrating sensing information, no matter how we obtain it, in the operation with for the cellular network or Wi-Fi networks or any other communication system. So in this figure, you can see that we could also consider a form of ISAC, the deployment of sensors at the base station, and maybe combined with monostatic sensing to improve sensing performance. And in the same way, we can combine different sensing modalities. These are areas that are not that well developed, but are very, very interesting too. And then in the special issue, we also discuss a bit on the integration of model and data-driven solutions. We believe that it's very interesting to use AI when it's really suitable for the problem to be solved. And we have very good models. We have developed many interesting solutions that rely on well-established models, but there are other situations where we have to handle limitations in those models, for example, to deal with hardware imperfections, synchronization issues, estimation errors. So ML is very, very interesting to handle both limitations in the models and also in the methods, because we may be developing methods that are too complex. We need to find other ways to solve particular problems. In the special issue, we also discussed a little bit about sensing-aided communication. This means how can we exploit the sensing information to enhance the network operation. We could use sensing information, for example, to predict blockage. If we know all the scatters, objects that are in the environment, because we are sensing the environment, then we can predict that maybe, for example, one vehicle on the road is gonna block the communication link of another vehicle. We can also apply this philosophy to other problems, like designing the BIM codebooks. If we have information about the environment, we can design codebooks that maybe do not focus on spatial regions where we know that communication, the communication users or the sensing targets will not be located. And then, as nascent areas that we mentioned in the special issue, but at that time, really, there wasn't enough work to cover, to justify a tutorial, are related to, I think, the integration of multiple frequency bands. We have exploited carrier aggregation in cellular systems for many years, but the multiband processing for sensing is not that well developed. And this is very interesting for new frequency bands, for example, when we have to operate in the upper mid band and also lower bands at the same time, and maybe switching from one to the other. And there are really many interesting problems to solve here. To me, the most interesting personally area right now is the integration of the network elements to implement the sensing functionality. In the tutorial that we published in the special issue, we focus, as I said, on monostatic sensing, bistatic sensing, which are single link sensing modalities. We just consider one transmitter, one receiver, can be the base station or the user, either way, but we do not consider the full potential of the cellular network to operate as a sensor, as a whole. So this means putting together different base stations, different users to send the environment in a coordinated way. This, of course, introduces many challenges related to synchronization, mutual calibration, even accurate positioning of the users if they are performing sensing operations. So it's really a very, very exciting area where you can work on if you are attracted to this ISAC research area in general. And in my group, we are following this trend. We have been contributing to this area, developing solutions for monostatic sensing, exploiting full duplex circuits, a lot of work with our sponsors in industry on vehicular localization, many other problems. But right now, what we are focusing on distributed ISAC with applications on drone detection, smart factories with collaborative robotics, and also automated vehicles. And I think it is still a super interesting area, and I hope you enjoy the tutorial, and I will be ready to answer any question related to this topic. Thank you.